teacher, that's cool.
Yeah, no, you're a good
as
teacher.
long as you tell me why I'm a bad teacher, it's all good.
I can tell you why.
Constructive criticism is good. Yeah. The only time it doesn't really help is when people just say, "Tag, you suck." Okay, well I know that, but why? Not knowing why is the problem.
No, he would go from the book, and we would ask a question.
It's being recorded.
Oh.
Don't say your name.
Some unnamed professor.
Yes. Professor
It's like in Doctor Who, it's always just the Doctor, right? Does he even have a name? He has a name. Yeah. That's an interesting show.
What is it about?
Doctor Who?
Yeah.
It's a British science fiction series, and it's resurrected from the black and white days, so the new ones are actually, just the resurrected version of that. And it's a very British thing, so if you're used to the Next Generation or Star Trek, that sort of thing, it's not really quite like that. I mean, it's very dry, it has, complicated plot lines, and then they throw in some really British, humor into the mix too. It's very dry. Yeah. All right. So we are back to arrays, and last time we went through a few examples to illustrate, how to use arrays, and today we'll continue with that, to further explain, other things that you can do with arrays, and then what we'll do after that is to talk about. Go to topic 7. We're almost done with topic 6. I mean, topic 6 is really close to being finished. So we'll move on to topic 7 sometime today, and we'll talk about searching, an unsorted array, and also searching in a sorted array, because searching in a sorted array is a lot faster because of certain things that we can do about it. We'll also talk about short-circuited Boolean operators versus the typical Boolean operators that we're used to. Okay, so those are the things that we're going to cover today, and I will probably just go ahead and change the light bulb, to highlight the new portion. And for those of you who want to know your grade is now posted on Moodle. What you need to do is to go to, I think it's under settings. Under course settings, you have grades as one of the items. Just click that. And I know the grades are really confusing right now, but if you just focus on X1, X1 is exam 1, and that is the one that you need to focus on for exam 1. I have to say, as a whole, this class did really, really well in that test. So either I'm losing my touch, asking difficult questions, or I'm getting better at explaining things. I don't quite know which way it is.
It's kind of difficult, but I mean, because we had gone over it.
Okay.
We understood it, so we understood it.
It seemed that way. It seems like most people can understood the concepts, and that's why the class was doing well. So it's good. I mean, if you guys have any more questions about the second exam, the first exam, let me know. Yep, go ahead.
Is the final the 2 exams that we do?
Yeah, it's very much about the same stuff. Same style of questions, same kind of questions. Obviously, it won't be the same, but it will be very similar in terms of style. So you can basically expect, traces, that are partially done. You have to do some of the initializations. Just basically follow the instructions, and it won't be much different. Just a little bit longer. Yep.
So the final will be cumulative then.
The final exam is cumulative because in programming, a lot of the concepts have to stack on top of the earlier concepts. So it's pretty hard to, come up with an exam that is not comprehensive in programming. It's still open book, open notes in the final exam, so you can prepare, a bunch of material to help you out. If you think, okay, I may not be able to remember all of this stuff here, no problem. Just write it down on a, pieces of paper. Bring that with you, so you don't have to memorize everything. This class is not about memorization. This class is about understanding the basics, of programming. And that's what it's about. I mean, I don't want you guys to, waste your, brain juice or, neurons to, memorize things that you really do not need to. I mean, if you think about working, what do you think you have to do when you are working as a developer, as a programmer? Reference. Okay, you can have books, you can have internet access. So except for very few types of programming jobs where you really do not have access to the internet when you're working, for the most part, there's nothing that you have to memorize. I mean, you just have to look up, okay, how do I do something like this in Perl or in PHP or in C? You can literally learn a new programming language on the fly. I mean, just over a few days, you just read enough sample programs, search for how to do certain things, and try to understand the syntax, and that's how you learn a new programming language once you have enough background under your belt. Okay. So the bottom line is the final exam is going to be very similar in terms of style and what you can bring to the test as the first exam. Okay. It's just a little bit longer. It's 2 hours instead of 80 minutes. So it's only longer by 20 minutes, not really by that much. Yep.
Will we be able to see our first exam to see what we did wrong?
You know what? I forgot to bring it back today. If I can pass it back in the next class, I actually had it in my office, but I just forgot to bring it here. But if you're really concerned and you cannot wait, you can either follow me to the office, I can bring it to you, or I can send you my photocopy of your exam so you can get it back, quote unquote, get back the photocopy before next Tuesday.
All right.
Yep. All right. So getting back to arrays, are there any questions about arrays? No questions? Okay. All right. If there are no questions, I'm going to just go ahead and move forward and start to talk about short-circuited Boolean operators, because that's actually needed in order to. Oh, okay, that's the wrong thing to modify. I think it's this one here. I have to change the way they display, because the default just doesn't work. All right, so we have it. Okay, this method of short-circuited Boolean evaluation is also called the lazy evaluation method. Okay, so what I'll do is I'm going to start to talk about how to search for an item in an array, and from that context, we'll talk about what is short-circuited evaluation. Okay, so we'll start with the pseudocode for that algorithm. And instead of just giving you the algorithm, I want you to kind of help me to derive the algorithm, to synthesize or create the algorithm on a step-by-step basis. Okay, so here we have our trusty notepad, and what do I need to do in order to find an item in an unsorted array? Okay, so let's just imagine that you have a huge stack of cards. Okay, each one has a number on it, but the stack of cards is not sorted in any particular order. And I want you to find me a particular value. How would you do that?
You have to iterate through the entire thing.
Yep. And what would be the usual way that you go through the stack of cards? Would you pick something in random from inside the stack? From start to finish, okay? So in a particular sequential order, right? Okay. So I'll just give you one example here. And instead of using this, I'm going to use a spreadsheet to help me kind of explain that. Because I think a spreadsheet really helps because it has, the natural, table look already. So I'll give you an array. Okay, so in this case, okay, random. Okay, that's just a random number between 0 and 1. I'm wondering whether it has another one that can give me a range, but that's okay. I can work with this.
Multiply by 100. Just multiply by 100.
Yeah, I can just multiply this one by 100 and then take the floor of that. So that way it is just an integer. Okay, floor takes 2 arguments. There we go. All right. So column A is not really that important. I just want to make this large enough that it's not trivial. So I'm going to hide column A here. All right, so column B is, just, a whole bunch of numbers. It's completely random, so that, so there's no particular order. You cannot say, oh, I know where to find that number because there's a certain pattern to it. Nope, there's no pattern whatsoever. In column C, I'm going to, look for, okay, not in column C, but let me just insert a row here. And I will say we are looking for a particular value. Okay, we're looking for, let's see, what value should I be looking for?
15.
Between 0 and 99. Go ahead.
15.
15. Okay, so let's, well, 15 is already here. Let's pick a number that is not here.
Oh, 30.
How about 31? Well, it keeps changing. Every time I type a number, it changes. So let's try to find 31, okay? Now, if I just give you like 5 items, in column B, you would not be able to tell me a systematic and structural way to look for that item, because you can eyeball, right? Because we can easily track 5 or 6 items on the screen, and we can just say, oh, it's there or it's not there. So you would not be forced to use a more structured way to look for a particular item. In this case, because we have so many items, it's not that easy to look for a particular item. So in that case, you also have to kind of remember the computer doesn't see the array the way we see it. It cannot see multiple items at the same time. The computer looks at the array kind of more like this. Okay? In other words, it can only focus on one item at a time. And so, well, if that is the case, then we have a problem, because we cannot just eyeball a whole page and say, oh, 31 is not here, page down, look at the next page. We have to look at each and every item as we proceed. Okay? So what we'll do is I'm going to use a particular feature of a spreadsheet, which is a conditional statement or conditional expression in a spreadsheet. I can actually perform a test of whether this cell equals to C31, excuse me, C1 here. And if it is the case, we say found. If it is not the case, we say not found. So, okay. And because the numbers keep changing, so that makes it kind of interesting, right? So I'll just kind of drag it down here, so we can kind of get a feel of what I'm trying to express. Okay. Okay, there's a found. Okay. So the way it works is, okay, you compare the first item to the number that we're looking for. It doesn't match, and then what do you have to do? Move on to the next one, right? Look at the second item. The second item says, oh, it's not the one that we're looking for. Look at the third item, the fourth item, and so on, until we get to the one that has the same value, the one element in the array that has the same value as what we're looking for, and then we say found. Now, if my objective is really just to see whether a particular value is in an array or not, do I have to go any further? No, I can stop right there. I can just say, hey, I found what I'm looking for, and I don't need to go any further. On the other hand, if I cannot find what I'm looking for, I have to keep going until what?
You find it.
Or it ends.
Exactly, until I hit the end of the array. Then I will say, well, I have examined every single element in the array, and yet there's nothing matching the value that I'm looking for. So my conclusion is the item that I'm looking for is not in the array. Okay. All right. So this is just an example of doing it by hand. Now we want to write an algorithm to do exactly that. Okay. The first question is, does it seem like I'm doing something repeatedly?
Yes.
Okay, it has repetition, so we'll say loop. And are we going to exit the loop at some point, or is this an intentional infinite loop?
Exit once you find it.
Okay, we have to exit at some point. So we'll go ahead and express, when do we exit from an algorithm whose responsibility is to confirm whether an item is in the array or not? So when do we
When you reach
exit?
the end of the array.
When we reach the end of the array, that's one, and
Or
when we find the item. Okay, so maybe I can just make it really vague for the time being. When we confirm whether an item is in the array or not. Okay, how's that? That's really awfully vague because it doesn't say anything about how to determine make that determination. Okay. All right. Well, that's okay. Because that by itself is important. Okay. The next question is, now that we know we can exit whenever we confirm whether an item is in the array or not, maybe we should separate it into two things and then use disjunction or to merge the two. Okay. So one thing I'm going to do is to make this just slightly more clear than the one before, which is doing it like this. Okay. When we confirm an item is in the array, or we confirm an item is not in the array. Okay. And then we call that, hey, this is good. We have another revision here. All right. Looks like we can use some terms here because an item that sounds kind of vague. Okay, what we're looking for, and also the array is also kind of vague. So maybe we should use some programming concepts here. Maybe the use of variables in this case. So we'll go ahead and start to use variables. So we'll say let k be the item or the value that we are searching for, which is also known as the key, and that's why it starts with k. And then we'll say let A be the array in which we are searching for the value in variable k. Okay, fine. It's easy. We can just say that instead of saying we confirm an item is in the array, we can say k is the same as A bracket something. We don't know what that something is. Okay, we are still trying to work out this algorithm. But the notation of A square bracket with a question mark inside means k is the same as one element at least in the array. Okay, that's what I'm trying to express. Is that okay so far? Okay, I don't quite know how to do that question mark. How to make it how to find a question mark. But I know that if k is the same as some element in the array, which is what the A bracket close bracket notation is about, then we can exit. We can exit right away and say, yes, it is found, we can get out of here. What about the other one? We confirm an item is not in the array. Maybe we can use about the same thing, and we say k is different from all A bracket something. Okay? All right? So we're basically saying, we confirm that k is different from every element in the array. That's how we can confirm that the item is not in the array. Are we still doing okay so far? Okay. How do we go through an array? Remember, with comparison, you can only compare a number to a number. In other words, it doesn't make any sense to say, A equals k. Okay, the comparison of an entire array to a single numerical value cannot happen because there's no way to compare these two. They are not the same thing. So that means whenever we compare, we can only compare an element of A to the value in variable k. So that means I need something to help me identify which element I'm comparing to k. Because I know I need to compare in order to confirm that k is the same as that element. So I need to make a comparison. I need something to help me determine which one I'm comparing to. What do you think is one way to do something like this? Yep.
The loop iterator.
Loop, we can use another variable.
A wildcard?
A wildcard? No, we don't have a wildcard in programming. In programming, there's no such thing as match something, because we can only examine something, we cannot match something. Now, in Perl, there is a match function, but you cannot just say, okay, match this value to everything in the array. That operator still does not exist. Okay. Remembering the algorithms that we discussed on Tuesday, what is one of the variables? What is the one variable that keeps changing? I typically call that I for index, okay? All right, so this time we'll use that also. So we'll say let I be an index to specify an element in the array, okay? To examine, okay? So once we have variable I, let's see whether we can change some of this stuff here, okay? Hey, if I is an index to specify an element in the array that we are examining, maybe if k is the same as a bracket I, then we can say, hey, I have just found the value that I'm looking for. It's time to exit the loop. Does it sound good to you? Okay.
So I is the element in that index position.
I is not an element. I is just a variable that I use inside the index operator, so it can help me specify which element in the array I'm looking at.
It's like a page number.
Right, it's a page number, but it's a variable controlling the page number. It's like a bookmark, so you can move it from one page to the next. Okay. Is that okay so far? Okay. All right, so that's good. I don't really quite know how to express k is different from all the elements in the array. So we'll just kind of leave it like, maybe we'll defer that. Okay, we'll kind of procrastinate a little bit, but we can still focus on I. Okay, there are certain things about I that we have to do, like how should we start with I? I mean, I needs to start with a particular value.
I get 0.
Okay, so it's not uncommon that we start with 0. We start at the very beginning of the entire array. You can also start it from the end and work your way back to the beginning. Either way works, but starting from the beginning, works a little bit better. We can make either way work, but this one is just easier. Okay, so now we have this statement here. We know it's a loop. We know that we can get out as soon as we find an element with the value that we're looking for. We know that we can exit the loop when we confirm all the elements are not the same as the value that we're looking for. But what do we do for each iteration? Every time we see, we compare to an element and we say, this is not what we're looking for, and yet there are additional elements after that that we have not examined yet, which means we cannot confirm the k is different from all the other elements. What do we do to I to move on to the next one? We just add 1 to it, right? We just move on to the next item. And that can be done by adding 1 to I. And remember, I is not a special variable. It is really just an ordinary variable storing an integer value. What is special is how we use I. Okay, we are using I inside the square bracket, and that's why that's the special part of this program. It's just that we are using I inside the index operator of the comparison here. Okay, well, I think the algorithm is kind of shaping up. Okay, that's good. But I'm still not getting the last part here, which is how do we confirm that k is different from all the elements in the array? Now this part is a little bit tricky because you kind of have to look at what we are doing for each step in the algorithm. What are we doing with each iteration? So if you start an array like this, okay, and we start with everything here not compared. Okay, in other words, we have not confirmed anything yet at this point before we get into the first iteration. For each iteration, we are moving I. Okay, so I is pointing, not pointing, but I is specifying a particular element. So at each point here, we basically say, okay, we can take one element out of the array and compare that to k and ask the question, is that the same or not? That's what we're doing for each iteration. But since we are moving I in a linear fashion, what can we say about the portion that we have already examined?
They are not equal.
They're not. Okay, very good. Because if one of these is k, we would have exited already. Very good. So that means as we move I along, okay, whatever is behind what I specifies, we can confirm that none of that has the value of k. So now the question is, how do we answer the second part of the question, which is the part on the screen that is now highlighted? How do we know that k is different from all of the elements in the array?
I is like greater than the number of items in A.
Okay.
Well, if it's not equal to the last element of the array, then it will not be equal to any of them.
Once, in other words, once I have examined every single thing and none of that match, right? But since I know this is the direction that I is going, so that means, right after, okay, this is the last iteration. When I is specifying the last element, I cannot exit just yet, okay? Because I'm just setting myself up to make the last comparison. But once I, is no longer specifying, once it is past the index of the last element in the array, then I know I have examined everything in the array and none of that is matching k, because otherwise I would have exited already, right? So how do I specify that over here? Okay, the trick is it has nothing to do with the square bracket operator, but it does have something to do with I. It has nothing to do with k, because we are just saying, oh, we have, I has now moved past the last the index of the last element in the array. How do we say that? What is in range? What is the range of indexes in any array? We always start with index 0. And what is the index of the last element in an array?
99.
Assuming it has how many elements?
Oh, I thought you said we were going from 0 to 100.
Okay, if it has.
Oh, so then 100.
Okay, but
Whatever you define it.
whatever I define it, but there's an operator that tells me something that's close to what it is. Okay, go ahead.
Square brackets.
Okay,
It's
no, not square brackets,
the
bars, the bars.
the
Okay,
bars.
okay, we know the bars are useful in this case. Okay, so we have bar A bar, okay, which tells me the number of elements in the array. But the number of elements in the array is not the index of the last element because we are starting with 0.
So I asked, would you have to do the length minus 1?
Length minus 1, exactly. So once I is greater than this value, we can get out. Is that making any sense?
Say it one more time, please.
Okay. The valid index in any array is going from 0 to bar A bar minus 1, which is the number of elements in the array minus 1. The minus 1 needs to be done because we are starting from 0. So if you just look at an array with 2 items, the valid indexes will be 0 and 1, not 2, right? So once I is greater than bar A bar minus 1, then we know that we have examined every single element in the array because I is like a bookmark, okay? It is separating the portion that we have already examined and confirmed that k is not there, and the portion that we have yet to examine, and maybe k is there.
Such that the number 1 does between 0 to the value of 0.99, then we define 1. We've actually went through the 0 hour, I guess you would say. Whereas we have 0 and 1. That's 2 increments. Correct, like you just said.
I'm not quite sure how to link what you said to.
Oh, we keep going. Maybe
Okay.
I'm trying to kind of go along as we're doing here.
Okay.
First roll, second, it's kind of like the bar A brackets is like a measure of distance, and if you just
Mhm.
look at a ruler, it doesn't matter whether you start at 0 or 10 or 50, you still get the same A. You just end in different places.
Okay.
So we're starting at 0 instead of starting at 1, so it just.
Where's it?
Yeah.
Yeah,
Like,
if you look at
if we started at 20, then we'd be minus 50.
if you look at this as a street address, if you look at each index as a street address in a block, 0 is basically the first address in a block, and bar A bar minus 1 is the street address of the last house in the block. Okay, so if a postman wants to know, am I done with this block? So if his index is moving past the last house number in the block, then he knows that we are done with that block. But it has to be greater than, not equal to, because when it's equal to, that means I have one more house to deliver mail, or in this case, to compare. All right, so what we're looking for, okay, we'll start with this one here. So we have I on one side because I is the bookmark, okay? It's very important because as the bookmark keeps moving, we're trying to say, are we past the end of the array? But we are comparing the bookmark to something. We also know that bar A bar minus 1 is important because that's the index of the last item in the array. Now that we have this picture, we can also say when I is greater than bar A bar minus 1, then we're all done because I is not even a valid index at that point, so why should we even continue? Okay, so we'll go ahead and do it like this. And the algorithm is close to being done, but not quite yet. Okay, so when you look at this expression here, and if I can tell you ahead of time, but you can actually infer that from the algorithm. I starts with a value of 0, which is an integer, right? And every time we change it inside the loop, we're only adding 1 to it. So that means no matter how many iterations we go through, I can only be an integer. It cannot be a floating point number, it cannot be a fraction. It has to be an integer, it has to be a whole number. In fact, in this case, it has to be a natural number because it cannot go negative. Okay? If I know that I can only be a natural number, what is the other way to say that I is greater than bar A bar minus 1? Bar A bar has to be an integer as well. Can we do something like this? Can we say when I is no longer less than bar A bar? Would that say the same thing?
Yes.
Because that's the same thing as I is greater than or equal to bar A bar, which given that I and bar A bar are both integers, is really saying the same thing as what we said earlier, which is I is greater than bar A bar minus 1. Okay? Does this look familiar to you?
Yes.
In the previous class on Tuesday, almost every single loop has an exit condition that has not, except for the negation part, has the component of I is less than bar A bar. We stay in the loop as long as I is less than bar A bar. Yep.
Good question. At this point, does the order of the way that you're
The disjunction?
setting up the disjunction, does that matter?
Well, that's the whole point I'm trying to drive to. So we'll get to that. Okay, that's a very good observation. Okay, I'm trying to foreshadow things that I will talk about. Very good job. Yep.
The roll sheet.
Row sheet. Excellent. Good reminder. In fact, I have a brand spanking new row sheet for today because we have just used up the previous one. Okay, so before we answer that question, let's turn this into something that we can actually run, then we can test it. The last portion is, do you think this loop here is a pre-checking loop, like a while loop, or do you think it should be a post-checking loop, which is a repeat until loop?
Repeat until.
Sorry?
The second one, repeat until.
Repeat until? Now, if it is a repeat until loop, what is the first index that you want to compare to?
0. No, negative 1.
Well, the first index that you want to actually compare to, or the index of the first element you want to compare to, is still 0. But that means you have to initialize I to -1. I think that's what you meant.
Yeah.
Yep. So we're
Because you
getting back to
have 0.
exactly. So we're getting back to the same problem of, do we want to use a post-checking loop? Because we can always make that happen, especially in cases like this. Okay, so I'll give you 2 versions, and you guys can say which one is better. Okay, so I can initialize I to -1, and then use repeat. I gets I plus 1 until, and then we can keep the same conditions because we are now specifying the exit condition, or I is less than, I is not less than bar A bar. Okay, so this one needs the negation. Okay, so that's one way to do it. The other way to do it is I gets 0, and then we can say while k does not equal to A bracket I, and I is less than bar A bar, do the following. I gets I plus 1, and while. Okay, so now we have 2 versions of the same loop, and they mean exactly the same thing. Okay, so they're both correct in this case. The question is which one is better, which one is more clear as to what it is doing and how it works. The second one, exactly. And the reason why the second one is better is because the first one has to initialize I to -1 because we have to go through at least one iteration. So by the time we get to the until line, in order for the first I or the first index of the element to compare to be 0, I need to initialize I to -1, which is artificial. Okay, we're artificially making it a negative number just to make it work. On the other hand, the second version is a lot more natural. We're just saying, okay, we start with the first index of any array, which is 0, and then we just specify it as a pre-checking loop, and that makes more sense. It's easier to track, it's easier to read, and if you make a mistake, it's also easier to correct. So that's why the second version is preferred, even though the first one is correct. It is not a good way of doing it. Are we doing okay so far here? Yep.
When is it good to use
The repeat until, a post-checking loop. It's only when the condition that you need to test doesn't make any sense until you have at least one iteration through. So an example is error checking for user input, because you have to say repeat. Well, you have to say repeat ask user for a zip code until the zip code is valid, because if you flip it into a pre-checking loop, like while the zip code is invalid, do ask user for input, then what are you comparing to when you first get into the loop? So that's one of the rare cases where a post-checking loop makes more sense, because the body of the loop is what you need in order to have something that makes sense for the condition to evaluate. Yep.
So maybe something where we are using X and Y, and what we would be checking the Y value when we start out with the Y value.
Exactly, something like that. So in order to make a pre-checking loop, when a post-checking loop is really a more natural way to do it, you can artificially make it work. You can have one additional ask user for input before the while. So by the time you get to the condition, the zip code actually means something. You can have another flag to basically say if this is the first iteration or the zip code is invalid, ask for input. So you can actually do about the same thing to make it work, but it is artificial and it doesn't look natural in that case. That's a good question. All right. So it does look like we have an algorithm that will work in this case, and we'll go ahead and give it a try. Okay. Yep.
I have one more question.
Mm-hmm.
Me, I just lost my train of thought earlier, but when you didn't need to switch around the comparison operator for I is less than.
That's because I took out the negation.
Oh.
Yeah, that's because I took out this negation here.
That's right.
Yep. All right. Okay, so let's go ahead and see if this will work in a trace. Now, obviously, this is not really the best way to verify this algorithm is correct, because remember, we can use pre and post conditions, but in a class like this, I'm not gonna keep using pre and post conditions. We'll just go ahead and make a few traces, and then we'll say, yeah, it's working, or no, it's not working. So we'll go ahead and start with this. While I have to keep the same form. While a bracket I does not equal to k, and I is less than bar a bar, do I gets I plus 1, and while k. So the algorithm is relatively simple. And we'll give it, different test cases just to see how well it works, for those test cases. In the first one, in both test cases, we'll set it up like this. We have variable I controlling the index. We have variable k specifying what we're looking for, and then we have array A. In this case, I can make A really short to make it work. So we only have 2 elements in this case. So element 0 has a value of, let's make it 3, and then element number 1 has a value of 5, and we are looking for something that is in the array. So let's say we look for 5, just to make it a little bit more interesting. It's still not very interesting, but this is a little bit better. So this one will work out fine. Okay, most of you can probably see we're going to exit at the right time, and nothing bad is going to happen in this case. And here we have I not initialized because it is always initialized in the code itself. And then we have line 1. Okay, line 1 is easy. I gets initialized to 0. And now we have to evaluate the condition. And I need more space in this case. All right. Let me comment a little bit wider. So, okay. What is A bracket I? What is I anyway? I is 0, so A bracket I, oops, okay, need to do it on line 2, sorry about that. Okay, do it again. A bracket I is A bracket 0. A bracket 0 has a value of 3. We are comparing 3 to K, and K has a value of 5. So 3 is different from 5 is true. And then we have a conjunction here, I is 0. What is bar A bar? Bar A bar is 2 because we have 2 elements in the array. 0 is less than 2 is true. So we have true and true. And the whole answer is true. Okay, very good. Okay, no big deal. We go to line 3. We add 1 to I. I goes from 0 to 1. We go back to line 2. And then we have A bracket I is A bracket 1, which has a value of 5. And we are comparing that to K, and K has a value of 5. 5 is different from 5 is false. Now, but since this is a conjunction, I still have the right-hand side to evaluate, right? Okay, the right-hand side is I is being 1, right? 1 is less than 2 is true. So we end up with false and true, which is false. Okay, and then we get out of the loop. We're done. Okay. I'm missing the last piece here, which basically says whether we actually found the answer or not. But I'm more concerned about getting out of the loop at the right time at this point. So we'll focus on the other part later. Okay, seems like it works fine. I mean, we did exit as soon as we find an item in the array that matches the value that we're looking for. The algorithm is exiting at the right time. No problem. Okay, so the next thing we'll do is to do about the same thing, but this time we're looking for something that is not in the array and see whether it can handle it or not. So even if you're not using pre and post conditions to verify your program is working, you should still at least try your best to exercise as much conditions in your algorithm as possible. Okay, without using pre and post conditions, yeah, you might miss some of the red dots inside the green circle. But still, it's better than not testing it at all. Okay. All right. So this time I'm testing it and say, okay, what if something is not in the array? It should still terminate, but is it going to terminate in this case in the right way? So we'll go ahead and take a look. Line 1, same thing. I gets initialized to 0, and then on line 2, no biggie here. Okay, because the first iteration is really the same as the last one. Last time. A bracket I is A bracket 0. A bracket 0 is column E. It has a value of 3. We compare that to K, but this time K is 4. 3 is different from 4 is true. No problem. And I has a value of 0. 0 is less than 2, which is bar A bar, is also true. True and true is true. We go to step number 3. We add 1 to I. This is cool, no problem. Okay, just like in the first test case. We go back to line 2. This time it's going to be a little bit different, but we still don't have a problem. Okay, I is now 1, so A bracket I is A bracket 1. A bracket 1 has a value of 5. We compare 5 to K, which still has a value of 4. 5 is different from 4 is true. Okay, but that's definitely fine. I has a value of 1 at this point. 1 is less than bar A bar, which is 2 is true. So we have true and true. Okay, true and true is true. We go to line 3. We add 1 to I. I goes from 1 to 2. Up to this point, the algorithm is doing exactly what it is supposed to. Okay, because we have to move the bookmark past the last element in the array. in order to confirm that yes, we have seen everything and none of that matches the value that we are looking for. Okay, so up to this point, we are fine. I mean, I is supposed to go past the end of the array. The problem is when we get back to line 2, this is creating a problem because the moment, okay, let me get rid of this part here because the problem has to do with this part here. At this point, what is the value of I? It's 2. Where is A bracket 2? It's not here. Because array A only has 2 elements. A bracket 2 is trying to access the 3rd element, which is not existent in this case. So we talked about this on Tuesday already. In Visual Basic, if you have a program structured like this, the Visual Basic program will basically give you a runtime error, and it will complain and say on line 2, you're trying to access an array A out of bound, and then you know what to fix. Okay, you know what the problem, where the problem is, and hopefully you know how to fix it. In C, it's going to be different, because in C, what will happen is the C compiler or C++, I kind of use those 2 terms, kind of interchangeably. For the discussion of this class, they are really equivalent. In C, what this will do is it will assume that array A starts on column E. So if you ask for A bracket 2, it will go to column G in this case and grab whatever is in column G and compare that to K, which is probably not what you want to do. Right? So we have a problem. This is not going to work. In Perl, it's even worse. In Perl, PHP, and Python, it's even worse because whenever you try to access an element in an array that is not there yet, it will extend the length of the array so that the element that you're looking for will start to exist. So it will basically just say, you want the 3rd element? No problem, I'll make it right now. So A bracket 2 just poof, starts to exist right now with a default value of something, okay? Which is probably not what you're looking for. It's not going to match K, but that basically makes this an infinite loop because it will keep creating new items in the array that does not match the value that you're looking for. So it becomes an infinite loop. It will only terminate when the Perl interpreter can no longer allocate another column or another place for your new elements. Then it will stop and say, I'm running out of memory. Crash. Yep.
So it won't randomly happen to generate the value you're looking for?
No.
It
Perl
doesn't,
does
like,
not do
increment or
random
anything?
thing. Perl, whenever you create a new object or variable or something that can store a value, it always starts with the so-called undefined value. Yeah. But it doesn't match K. It's not going to match
just
K.
keep putting that.
Yeah, but this will keep allocating, so your array gets bigger and bigger, but the loop is not terminating the way it's supposed to. So no matter which way you go, Visual Basic, which just gives you a runtime error, which is actually the best way to handle this situation. C will just grab the next location and say, well, if A had, A bracket 2, it would have been here. But it doesn't know that A actually only has 2 elements. Yep.
Is there a way to restrict it from generating another element in the array?
In the other languages, I do not think there's an option to force it not to extend an array.
Just gotta write your code.
You got to write your code properly. Yep.
Is there a bad, what if you just, before you did that comparison, assign the length of your array to a variable and just compared that variable? Is that bad for other reasons? Or
That would be a good way to do it. Yep. But there's another way to get around this problem. Okay, the problem that this is occurring, this one is easy to fix, and most of you go like, really? That is going to be the fix? Doesn't seem to make any sense. Well, that's because it doesn't really make a whole lot of sense. And I'm going to change, even the font color of this one, so that we can highlight where's the problem. Okay, the problem is we're trying to access A bracket 2, and it doesn't exist. Okay. All right. So this is not good. I mean, this program is not going to have the right behavior. So how are we going to fix this? Okay. So let's go ahead and save this one first, and we'll call this bad search. Okay. Now we can save it again and call it good search. Okay, in the good search, we're gonna do just a little bit of a change. What I'm gonna do here is I will just say, oh, you know what? We'll do the compare to bar A bar against I first, and then we'll do the inequality check whether A bracket I is different from K. And right away, if there's a mathematician in this class, or if a math professor is sitting here, the math professor will protest right away and say, but conjunction is supposed to be commutative, which means reversing the order is not going to change a single thing. And then my answer is, that's why you're in a programming class. Yeah.
It's the logical test and an answer in a conjunction statement. As long as one side is false, the whole thing is false.
Yep.
Yeah.
It's making use of the fact that when one side is false, the whole thing is false, and we are lazy. We don't do things unless we have to, which is something that mathematicians usually don't get. Is we don't do things unless we have to.
Foundation of computer science here.
Well, in computer science, efficiency is a concern. So it's not really just whether your algorithm is valid or correct or not. It is also, how efficient is it. Yeah. Okay, so we'll take a look at this one, and then we'll redo the trace that was problematic. Sheet 2 is not problematic. Okay, the only thing you have to do to sheet 2 to fix it is really just to reverse these two orders so that the trace matches the algorithm, right? So all you have to do is to go here and then say, okay, we'll fix the order of the comparison, and that's it, because it doesn't really change the answer. But in this one, I'll still go ahead and kind of explain it a little bit. Okay, so in this one, I is less than bar A bar is true at that point. Because at this point, I has a value of what? If you just look at the trace, I has a value of 1, bar A bar is 2, I is less than 1 is less than 2 is true. So with a conjunction, when one side is true, do you know the entire thing is true?
No.
No, because it becomes false when one side is false. Okay, or at least one side is false, I should say. So that means the other side can still make it false, and that's why you have to evaluate the other side. And in this case, the other side is false because A bracket I is 5, K is 5, 5 is different from 5 is false. And that's why we can make the conclusion that it is false. So in this case, there's no laziness. Okay, you cannot be lazy and say, okay, I can evaluate one side and be done with it. But then somebody's going to say, but if I really want to be lazy, I can choose the side that is false to evaluate first. Then I can be lazy and say, we won't have to evaluate the other side. This is the other thing that you have to understand about C, is when it comes to logical expressions like and or, it always evaluates from left to right.
How you read.
Exactly the way you read it, okay? Well, the way European languages are read, okay? Because there are natural languages that read the opposite way. So it's basically the way we read English, which is from left to right. Okay, so C does specify that as a part of the language specification. When it comes to conjunction and disjunction, it always evaluates the left-hand side and then, if necessary, the right-hand side. Okay? If I understand it correctly, this is also true for all other programming languages that are derived from C. So that would include Java, PHP, Perl, Python, and so on and so forth. Basically, any modern programming language would do the same thing. Okay, so in this case, it's just a change of the ordering of the operands or the expressions on the two sides of the conjunction, but not really much else. Okay, so it doesn't seem to have a whole lot of impact. If we look at the case where it did not work before, let's see what happens here. Okay. So in the first one, because both sides are true, so it's really the same thing. So whether you evaluate I is less than bar A bar first, or A bracket I is different from K, doesn't really matter. And I can say exactly the same thing about the second iteration. When we evaluate the same condition the second time, it's the same thing. Because when you evaluate the right-hand side, when you evaluate the left-hand side, it's true, but with a conjunction, we cannot conclude the whole thing is true or false just because one side is true. So we have to evaluate the other side. So it's basically the same thing as last time. But when we do it the third time, it's different. Okay, so in this case, we have to kind of clear the formatting first. So I'm going to go to delete content and get rid of the format. I forgot to specify that. Content, and we want to delete formats. Here we go. So the color is gone. Okay, so this time we'll go ahead and try to evaluate the first one first. I is 2 already at this point. 2 is less than 2 is false. If one side of a conjunction is false, the whole thing has to be false. So the logic of short-circuited evaluation, which is also colloquially called lazy evaluation, is saying, hey, if the left-hand side of a conjunction is false, there's no need to evaluate the right-hand side. So I don't even bother to evaluate the right-hand side. So the problem that we had earlier, which is accessing an element out of bound, does not even exist now. Because the first condition has to be true in order for me to evaluate the second condition. But the first condition being true, meaning I is less than bar A bar, guarantees that I is still a valid index when we get to the right-hand side. Are we doing okay so far with the logic here? Okay.
I see where you term lazy or
Short-circuited.
yeah.
Short-circuited
You're
evaluation.
just drawing a line from one place to the other, skipping something.
Right. And you can do the same thing with disjunction, except the polarity is switched.
Okay.
With disjunction, if the left-hand side is true, then the whole thing is true, so you don't bother to evaluate the right-hand side. But with a disjunction, if one side is false, you still have a second chance to making it true. So then you have to evaluate the right-hand side if the left-hand side evaluate is too false. With disjunction, with OR.
Do we get into any out of bounds situations with the disjunction then?
Say again?
Is it possible to get an out of bounds?
If you code it incorrectly, you can always have that chance, to happen. But in this case, because of the way we set up the loop, we need a conjunction in this case because we need 2 conditions to be true to continue to stay in the loop. Right. So are there any questions about short-circuited evaluation and why it works? So this is one thing that you have to pay attention to because in math, conjunction is commutative. But in programming, it is not. Okay, the order does matter in this case.
This is something that as we're tracing or as we're trying to validate one of our algorithms that we will have to manipulate to a certain extent now. That we've been given this option or given this resource.
In this class, when you trace algorithms, you always assume conjunction and disjunctions are short-circuited in this class.
Okay.
Because this is a prep class for cisp 360, and in cisp 360, conjunctions and disjunctions are short-circuited, so we'll use that convention, which is actually a valid assumption for most, if not all, modern programming languages,
So
even in Visual Basic.
So the possibility of any out of bounds or for our purposes in this class is negated. We're not going
If you
to-
order it incorrectly, you can still get out of bound. It's just in this case we use the proper order to make it happen. Now there's another thing I want to kind of mention, which is not something that I will quiz. The first condition in a conjunction is also called a guard condition for whatever else is after that. It's called a guard condition because if the guard condition itself is false, the rest doesn't execute. So in a way, it is actually helping to guard the right-hand side from a erroneous condition or a condition that is not good. So it's also called a guard condition. The left-hand side is called a guard condition.
Only in a conjunction.
Only in a conjunction. In a disjunction, you can also call it a guard condition, but the guard condition has to be false in order for the other condition to evaluate. So it's the polarity is opposite. But it's still a guard condition, meaning one can short circuit and not evaluate the other side. All right, so this is good. All right. So now that we have the good, the bad, we'll have the ugly. I can see from the response, I can kind of gauge the age group of this class. Okay? The lack of response here. The good, the bad, and the ugly. Come on, it's classic.
Just choosing hard.
Spaghetti Westerns. Spaghetti Westerns.
Yes, spaghetti westerns, which were not produced in the United States, and that's why it's called spaghetti, right? Where was it produced? What do you think?
Italy.
Italy, yep. Italians are kind of interesting. They make certain products that are kind of it surprised me. Okay, I'll just put it that way. I mean, they produce what, sports cars and spaghetti. Sports cars that can be powered by spaghetti now. That would be something. Here's my Ferrari, and I just need to give it, like spaghetti, and it would go. Okay, so let's go ahead and look at the the ugly one. Okay, what if there's no short-circuited evaluation in a programming language? In other words, whenever you have a conjunction, it always evaluates the two sides.
That means we've passed cisp300 and we're safe.
Well, that means you're programming in Pascal. Because there are ancient programming languages that do not implement short-circuited evaluation. Now, what if you are at work, you're dealing with a programming language that is new to you, and you don't know whether it has short-circuited evaluation or not? What would be a safer assumption? That it has, or it doesn't have short-circuited evaluation? That it does not. Okay, you want to make the assumption that it does not have short-circuited evaluation, because if you write an algorithm that will work without short-circuited evaluation, it works just fine with short-circuited evaluation. Okay, it's just that it's a little bit more cumbersome, the code is a little bit longer, but it will still work. All right. So now the question is, because it's ugly because we have to do certain things to make it work when short-circuited evaluation cannot be assumed. Okay. How do we deal with that? Okay, so instead of just deriving the algorithm from the start, I'm going to give you the solution. Okay, the solution is like this. What you need to do is to use an extra variable to keep track of the second condition that you need to evaluate. In other words, whatever can become a problem, in this case it is this part, you have to isolate this inequality comparison from the conjunction itself. Okay? And the only way to isolate it is to use another variable to keep track of this condition. Am I doing okay so far with that? Okay. So the way to do it is not to have it here, and then we'll substitute it with the negation of a variable called found, and then found is initialized to false because we are making an assumption that whatever we are looking for is not in the array unless it is proven that it is in the array. Okay? So that also means inside the condition here, we will need to do something about found, because if found is false to begin with, that means not found is going to be true, right? So that means the loop is not going to exit anytime until I is out of bound, then it will get out of the loop. So we need to do something about found so that it can get out early when an element in the array does match the value. And the quickest way to do it is simply to say found as a Boolean variable, a variable storing a true-false value, is really just the result of a bracket I compared to k, and we're looking for equality in this case. Okay, let's just take a look at this line and see whether it makes sense or not. Let's just look at, okay, I'm going to renumber the lines a little bit here. If we just focus on line 4, does that seem to make sense to you that a particular element in array A has the same value as k? Then we can say, hey, it's found. Seems to make sense. Okay? And it does go well with the assumption on line 2, which basically says, well, at this point, I haven't seen a single thing in the array because I'm not even in the loop yet, right? So the assumption is, if I haven't seen anything in the array, I'm going to make the assumption that it is not there. Okay, I only confirm when I see something that is what I'm looking for, but before I get to that point, I'm going to make the assumption that it is not in the array. So when you read line 3, it makes sense, because what it's saying is, as long as there are additional elements that I have not examined yet, and whatever I have seen is not matching, the variable or the value that I'm looking for, keep doing this. So it makes sense. Let's go ahead and trace this one and see whether it works or not. So the way it traces is, we have to insert one more column for found, and it's going to be, it will have an uninitialized value to begin with. And we'll just resize this one to this much. I'm going to close the ones that I don't need. This one we don't need. Close. Okay, this is the algorithm. All right, so the good, the bad, and the ugly, and take one. Well, we have 2 takes, so this is take 1. Line 1, line 2, pretty easy to deal with. Line 1 is just, line 1 initializes I to 0. Line 2 initializes found to false. So I'll just put an F here, found, false. And we can make the column a little. Nope, this one is actually going to be a little bit longer. It takes a little more room. That's okay. On line 3, we evaluate the condition. I has a value of 0. 0 is less than 2 is true. And found is false, not found is true. We now have true and true, which is true. Then we go to line 4. We have seen something like this already from Tuesday. Okay, we have a condition on the right-hand side that gives me a true-false value. We'll just go ahead and store that value. No problem, we can do that. A bracket I is A bracket 0 because I has a value of 0. A bracket 0 has a value of 3. 3 equals to 5 is false. So we are storing false in found again. Okay, so we just put it there. Then we go to line 5. We add 1 to I. I goes from 0 to 1. We go back to line 3. And basically the same thing happens here, right? Because I is 1. 1 is less than 2 is true. Found is false. Not found is true. So now we have true and true, which is true. We go to line 4 again. But this time on line 4, we are comparing A bracket 1 to K. A bracket I is column G. It has a value of 5. K also has a value of 5. 5 equals 5 is true. And I use that to update the variable found. And then we go to line 5. We add 1 to I. I goes from 1 to 2. Then we go back to line 3. And I is now 2. 2 is less than 2 is false. And then we get out right away. So we don't even use the variable found in this case. But if A bracket 1 was not the last element, it would have exited because of the other condition as well. Yep.
How come in the found column where you return a value of true, why wouldn't you return a value of I bracket for A bracket I equals K?
Because
you're assigning to the found column, right?
Because in a column, I can only store a value. I can only store a literal value, like a number, like 5 and 10. I can store a Boolean value, which is true or false, but I cannot store an expression. What you're talking about is an expression, but the truthfulness of the expression or the value of the expression changes over time. I can only write down something that cannot change over time. So in this case, true and false are values that cannot change over time. If you look at column C, variable I, it has values of 0, 1, and 2, but 0, 1, and 2 cannot change over time because they're constants. Okay, that's a good point because I have seen in the past, people just writing down the comparison itself, which is not good because I need to know the result of the comparison, not the comparison itself in a trace. Okay, so sheet 2 is good. Let's look at sheet number 3, and we'll do about the same thing here. We have a new variable called found. It has no assumed value to begin with, and then we'll trace this and see how found will help us get out of the loop and avoid the problem that we had earlier. On line 1, we initialize I to 0. On line 2, we initialize found to false. And on line 3, we get into the loop. It's the same thing as last time, so I'm going to just say, I is less than bar a bar, and not found is true. Go to line 4, found is going to be false, because in this case, we're comparing a bracket 1, which is 3, to k, which is 4. 3 equals 4 is false. We go to line 5, we add 1 to I goes from 0 to 1. We go back to line 3. Basically the same thing, because false is still, found is still false, and I is 1, and that's why the conjunction is still true. Go to line 4. This time we're comparing column G, which has a value of 5. You can't really see it. Let me change the size here. So column G has a value of 5. We're comparing that to variable K, which has a value of 4. 4 equals 5 is false, so that's what we are storing into variable found. We go to line 5, it adds 1 to I goes from 1 to 2. We go back to line 3, and this time I is less than bar a bar itself is false, so we get out of the loop. And we even have the right answer in the variable called found, because in this case we're saying, hey, I'm sorry, we have to get out of the loop, and yet I have not seen any element in the array that matches the value that we're looking for. So that's why it's called ugly, because it's longer for one thing, and then you also need an extra variable in order to get it to work. Yep.
If line 4 is true, we must type true in the column.
Well, let's try another take. Okay, we got 5 more minutes, so we can have take 3 with this particular scene of the bad, the good, the bad, and the ugly. All right, so we'll go ahead and make the first element what we're looking for. Okay, that's all I need to do to make use of found to get out of the loop. Okay, so basically the same thing. Initialization. Same. I gets initialized to 0, and found gets initialized to false. No big change here. On line 3, we are comparing I to bar a bar. I is 0, bar a bar is 2, 0 is less than 2 is true. Found was initialized to false, not false is true. We have true and true, which is true. Okay, so no change here. We go to line 4. Line 4 is comparing a bracket I, which is now a bracket 0, because I equals to 0, to k. Well, they are the same. A bracket 0 has a value of 3, k has a value of 3, so now we store a value of true in found. Then we go to line 5, we add 1 to I regardless, so I goes from 0 to 1, then we go back to line 3. Now on line 3, we have I less than bar a bar. I is less than bar a bar is still true because I is 1 and bar a bar is 2, 1 is less than 2 is true. So even with short circuit evaluation, we still have to go for the second one, okay, in this case. But in this case, we're assuming there's no short circuit evaluation, so we have to evaluate the right-hand side anyway. The right-hand side is not found. Found is true, not true is false. So now we have true and false, which is false, and we still get out of the loop with the correct answer stored in found. So this is the third case that really shows you how the variable found is useful in order for me to get out of the loop early. Are there any questions about the whole concept of short-circuited evaluation? There are very few languages that are still in use that doesn't use short-circuited evaluation. So no matter whether you're using Visual Basic, C, C++, Java, or anything derived from C and C++, they already use short-circuited evaluation. But if you encounter a new programming language or a programming language that is new to you, like COBOL, okay, then you may not want to make any assumptions. And the only way to make it work, whether it has short-circuited evaluation or not, is to use something like this. Okay. On next Monday, next Tuesday, we'll start to get into search algorithm. This is already searching, okay? But on Tuesday, we'll get into binary search, okay, which is a very interesting algorithm. And for the first time, we'll also talk about what is time complexity in an algorithm. Yay.
What does it say?
Okay, so let me stop the recording first.